Guys, thank you for coming to this talk. My name is Sebastian. I came from Poland. From a city of Łódź. I organized a Python meetup there, and I work for STX Next, the biggest Python software house in Europe. And I also write a blog on Python. The address is in the bottom of the slides all the time, so if you want to check it out, give it a go. And today's topic will be somehow a bit different from what you see at most conferences. There are very little topics regarding software engineering in Python conferences. This is somehow a crazy science that tells you about two things. First, how you solve problems with software, and second matter, how you solve your problems that you cause with the software yourself. And this is not a very popular topic. Usually we solve problems by installing next fancy libraries, hence the pip install slide there. And today I wanted to share you one of the concepts that emerged through last several years, and I did some practical appliance of this. And this is called clean architecture. So clean architecture is a thing about structuring applications that actually puts customers' concern in the first place. I will explain it in a minute. And it promises you to be independent of frameworks. So if you want to bump up a version or maybe a switch, but this is a rare situation, you should do it with less pain. You should be very easy. You should be able to test all of business logic without doing some things with database. You should not be restrained to some sort of user interface, and you should also be independent of database in the matter that you could always test without database or be able to switch it if you need it. But the most important thing is that it puts the customer's concerns in the first place. And I will show an example. Because we won't be talking in a void. I have a concrete thing to talk about. And imagine a project about auctions online. And here are some user stories, some scenarios that you might consider when you're implementing such a project. And the first one, as a bidder, as a person who wants to win an auction, I want to make a bid to win it. Another scenario, I want to be notified by email when I am the winning one. And the last thing, as an administrator, I would like to... Okay. Okay, sorry for that one. And as an administrator, I would be able to withdraw a bit. For example, someone is cheating, or maybe the guy asked for it, so I want to withdraw. And the framework that was chosen for this project was Django, of course, with a REST framework, because it's a super productive thing to do. And the Django gives us certain building blocks. These are things that we use to compose on our applications. So basically everything comes down to using models, and this is the first thing you usually want to write. If you have models, you can generate model forms, serializers, an admin panel, really, really fast. And that's what we do for the first time. So for such a project, we could imagine that we have two models. One is the auction, and the other one is the bid. And this has a relationship and so on. This is quite obvious, and this is the first thing to do. So a first thing to note, when you write a project with a Django, you start with a database. And to show you why you might want to take a different approach, I will focus on the first user story, which is withdrawing a bid. So you have an admin panel, and it's really easy to do. It takes literally to write 6 lines of code to get an admin panel when you can withdraw your bid. Very easy. But the problem is that this is not a trivial operation. You cannot just delete the records from database and expect that everything will be fine. Because if you withdraw a bid, current price of the auction changes. The list of winners changes. The new guys that are winners now need to be notified that they are now winning. So this is not a trivial. And you don't have to read this code. I will guide you through step by step. So first thing to do, you get from a database which bits you actually want to withdraw. The second thing, you count which are new winners, and then you withdraw bits using a method on the auction. And for the last thing, you just notify new winners. This is quite straightforward logic. Looking from a different perspective, this is one of the diagrams. And how does this look like from a different perspective? We have the guy, the so-called actor, administrator, who wants to evoke some action. And the system boundary, or the interface he uses, is admin panel. So our administrator via admin panel does what? Withdrawing a bit. And we have these two combined in our code. We don't see a distinction, yeah, because this is the one. And so the first thing I want to do, I want to make this a separate thing, so I can easily tell in the code where it is. And the use case for this would be, for example, I want to make an automatically ban people who are using dirty tricks. Maybe they're using bots to bid in the auctions. So I will expose an interface through a Django command, for example. And so, of course, this code now sits in the admin panel, so I need to pull it to another, maybe class, maybe function. And this is exactly what I will do. So I will make every use case, every scenario in the project, a separate function or a class, depending how complicated it is. And this is the first building block of clean architecture. You explicitly make every scenario a block code. This is called use case or interactor, depending what you need. This is the first thing. Think of it more as an as a conductor who orchestrates the entire process, who says something like, you, give me the object from the database, and you send an email. So this is the job of the use case. This is like a conductor. So let's digress for a moment. What about the testing? So when you see usual testing, the thing I came across over and over again in projects like on Django and so on, are that we test things via views. And this is also mentioned in documentation, that you have some endpoints, you make a request and check if the response is as you expected. So this test has several disadvantages, and the first, they are very slow. So slow that you spend majority of the time on testing the framework, which actually take for granted that it works. So it's also difficult to make sure that before the test, before the action, your system is in the right state. So if you need some objects to be in the database, you need to create it for every test, and so on, because test has to be isolated and so on. So if you look for a textbook example how the really good test should look like, you will see something like this. And this is not even similar in any way to what we saw in the previous slide. So you have a function that adds two integers, but actually what we want to see is how the tests look like. So this is similar that in the first place we have some preparations, so we tell what is expected. And the second, we do the action, and in this third line, we check it. This is what we expected to see here. So the problem here, actually not a problem, is that this is very easy, yeah? So why is this easy, and why my previous thing is very hard? So the idea is that these functions are called pure functions for functional programming. It means that they don't have any dependencies, yeah? They don't need to any prepared state in a database. You can always tell what will be the result of it, because it's independent on everything. And all it needs to produce a result is in the argument, yeah? And this causes that this test is very, very easy to reason and to write. So the note here is to take that if the function has no side effects, meaning no saves to database, no emails sent, and so on, and it has also no dependencies, that it will be very easy to test. And this is something that I would like you to focus maybe in the future. So people are doing different acrobatics when they're trying to test things, and this is not about trying hard to write more clever tests. It's more about writing more clever code that it's easier to test. So we have our use case and we would like to test it. So we have few things when we either have external dependencies or we have side effects. So first place, of course, we get from using Django ORM, we get objects. And so what's the standard thing to do with software engineering is that we introduce a layer of abstraction, meaning I no longer use Django ORM directly, but I have introduced some strange thing called auctions repository, which only thing I can tell from looking at this code is that it has a get method and it has a save method. I could write a class, a draft of it at least, that would look like this. Okay, so I only know that it has a get method that takes some integer, the auction ID, and it has a save method that takes the entire auction. And this is the building block number 2. This is called either interface or a port. So this only describes how your use case will contact with the outer world. Of course, actually code needs to do something. Yeah? So there will be a concrete class. For now, it's very simplified. That will actually get your objects from database. And this is called interface adapter or port adapter. So what we want to do, we actually want our use case thing that he uses the abstract class, not the Django one. For example, we may want to switch it for some mock in the tests without patching. For example, we would like, in the first place, we don't know what database we use, so we also might want to put some substitute for now. So the whole thing is that we want our use case don't know that this is Django. So we can't allow it that we create the Django adapter inside this class. We want it to pass it, for example, init. Of course, this would be impractical. So there is another thing called dependency injection, where we can actually pull it somewhere else and make it a configuration. So there it goes. This is like a giant dictionary. Whenever you ask it for the abstract class, it will give you some concrete class, but you don't know about it. This is somewhere else. So what we gained actually from another layer, except making things more complicated and more verbose. So first thing, it's easier to reason about the logic. You don't need to focus where your objects come from, what database are you using, and so on. And now it's possible to write true unit tests regarding your business logic, because you actually can get rid of any dependencies that external interfaces that you use in that way. Yes, and the work on a certain task can be parallelized. And this is more about teamwork, okay? So this is once I actually tried, and so a friend of mine worked on a use case when I was working on the repository. So actually the task was delivered quicker, and this is also a benefit. Yes, and probably the most important one, that some decisions may be delayed until you know exactly what you are building. Because in the first place, when you are creating a new project, this is a crazy moment, because you know you have no knowledge how it would work, how it will end up in the future. So this is what you want to delay. If you make any decisions, because you make the wrong decision, you will have to get back later, and this will cause pain and so on. So I lied to you for a moment, because I actually didn't make the most important thing. I'm still using the Django objects here, so what kind of decouple is that? None. So I will take care about this one now, because I don't want to use any Django objects in my business logic at all. And this is the last building block of clean architecture. This is called entity, and it somehow corresponds to the models, but not entirely. This will be a plain Python class that will have similar fields, just it's needed to carry out your business logic. And of course, the actual Django auctions repository must look a bit different, because we no longer return directly the Django object. Here's the thing. We get the thing that's underlying here, in this case Django object. We get all the bits that we need to also create an entity. and we translate it to ours. So this is the data repacking here. In that way, we no longer use the Django object inside the use case. And here we are decoupled. So the last thing that's left is to call the use case from maybe Django or maybe on every other framework, because it no longer matters. You are already decoupled in 100%. And if you put it in the one picture, it looks something like this. So in the center, there are your entities and maybe some auxiliary classes or something like, and so on. These are things that are true always in any context of your application. So for example, it doesn't matter who withdraws a bit. It always affects the auction. It will always affects the current price. So these are business rules that are true application-wide. So no matter how you do it, it's always there. Another layer is application, and this involves use cases and interfaces, so these abstract classes. So these two layers are actually your true business logic. This is where you want to have maybe 100 test coverage. You want to take a special note about this. This is when you took a special care. So the next layer is infrastructure, and these are all interface adapters. So you decide what database to use, who will be the email provider, and so on. And this is also the framework layer. So here you actually connect this thing to make it stand. And the most outer layer is the external world, like actual databases, operating system, and so on. There is one last important thing. These arrows, these are not there for no reason. So in the domain, you cannot use anything from the outer world. And this is true for the application. You can use everything that's domain, but you cannot use anything that's in infrastructure, at least not directly. And so on. This works that way. And this is another consequence. If you change anything in the infrastructure, you do not expect that anything in the inner circles will change. It doesn't have to be. But on the other hand, if you change anything in the domain, that you may expect that it will affect the application, the infrastructure, and so on. So here's the thing. But of course, I would be not honest with you if I say that this is a wonderful solution, there are no problems. Of course they are, and some of them may ever decide that you will never want to look at it again. So first of all, forget about idiomatic framework use. Yeah, so you will be actually no longer the recipes you found in docs will be helpful to you, because with Django, this is especially true with Django, because Django gives you everything, but on the other hand, it makes you to think and work how the authors predicted you to do. So you will struggle all the time to make sure that Django does not infer with your code. Yes, you will write more code, and this means like twice or even bigger. Yeah, because all these things are a bit verbose, you need extra classes and so on. So the code will be more in lines of code. Yes, and there will be some copying data between objects, and this is what you could see when I get the auction entity using auction model. You just repack the data, and this is somehow that happens very often in this approach. Yeah, and this is the biggest one, probably the validation, because when you use the Django, you just specify on the models what the length is, what's maybe some validation rules, and you get for free a validation on serializer and so on, and admin panel. This is very easy. In this approach, you don't have it at all. You need to either invent another mechanism, maybe just validate on the API, which probably will end up in some issues, or maybe you'll have to invent just another way to do it. But there's a counter-argument to this. You actually already doing validation on few layers at once. For example, when you have a web app, you have your validation of database and objects, but also you would like to have on the website, yeah, on the front-end forms. So you don't have to send the form to actually know that something is wrong. And the last thing is a danger of over-engineering, because probably it's very important to stay pragmatic, to stay lean. So we don't want to make everything complicated. the best thing is the simplest thing that works. So you don't get actually into details. And I know what some of you maybe all now think, that this is like firing the big gun, the heaviest gun I have in my artillery at the mosquito. So attacking the little problem with the heavy solution, and that's true for many cases. But here's the thing. Here's some situations where it actually pays off and it actually really works. So first of all, when you have a lot of cases, a lot of different situations that you have to deal with. So if you would like to test it all via the Django views, it will take hours to test. So another thing, yeah, this is what I was emphasis on layers, delaying decision making, because when you first start the project, you know very little about it, and maybe some decisions are not to be made in the first place. And the last one is a complicated domain or a complicated thing you deal with. So, because when you are using solutions that are ready off the shelf, that you are letting that somebody make the decisions for you. And you have to answer these questions to yourself. Whether you actually understand what you are doing, or you are trying just to fit what's told to you into these building blocks that you get, and not actually understand what you want to do. But this very depends on what case you're dealing with. Okay, so that's all, folks. Yeah.
When you use the clean architecture Django application, how do you divide the files in folders?
Yeah.
So you do it by feature. I think we'll get like very basic classes.
Yeah. So the first thing to remember is that forget idiomatic usage. So I tried different approaches. Yes. So I'll show the layers because it's the most okay. Okay, so usually I divide it as layers. So we have, of course I don't have the package for external world, it doesn't work, but I have the package for infrastructure, and this is a subdirectory with interfaces, adapters. I have a package for application, which has sub-packages for use cases and interfaces, and I have a sub-package for domain. And to make things a bit simpler and less writing, for the first time we did it as separate Django applications, but that's not what Django applications are for, and I don't think it was worth the shot. So just make it packages separate, and the folders, whatever you need inside. And there is another thing regarding Django integration. Oh, okay. So here it is, the dependency injection. Yeah. So when you are associating abstract classes with concrete implementations, and the problem is or not, this is a configuration of the project. So maybe you have an idea to put it into the settings, it won't work, because many things that you need are not yet initiated. But there is in Django a application ready callback since Django 1.7, and here you want to put it. So it will work seamlessly. Yeah?
Related to the interface adapters, as we know, we don't have like an interface type of Python as other languages. And many times I see that that is used the abstract-based class to implement an interface. So is that the only way to implement the interface, or there's any other ways of?
Okay, so actually, there is a way. So we have to remind what, yeah, because this looks a bit awkward. Yeah, maybe there are some better ways. So Python does not have this kind of idea as an interface, but it has something like protocols. So the protocol is when you, for example, there is a built-in function called next. Yes, so when you call it on iterator, then you get the next value. But this is all implicit, and you cannot just define the protocol. So to be true, to be honest, I think that actually in Python we lack something like this to define the interface more cleanly and more concisely. Because this look a bit verbose, yeah? Yeah, so to be brutally frank, I think this is a Python missing feature to somehow define it, yeah? Because there's also another thing. You had to inherit from this, right? So whereas, for example, in Golang, yeah, you actually don't need to introduce this type of this kind of inheritance, because when you define that, okay, I want something that will look like this, it will be statically checked that if you're really doing this. Yep.
Yeah, I don't use Django. I use other frameworks. I'm trying to track so the things that I find like commonplace, just about the entities. So what's the difference between an entity and a model?
Okay, so okay. So the concept is that in some cases there are business rules that you want to obey. That I will first do it in the models. Okay, so in some cases there are situations when you have a business requirements or rules that span over more than one model. Okay, so you, for example, has a user, and the user has some orders and so on. So if there are no limitations, for example, in how many orders can a user make, then you'll find you have separate models. Okay, but if, for example, you want to limit a user, that I don't want this user, any user, to make more than 10 orders per year, for example, then you want to make it one entity, okay? Because you have the business rules that will encompass more than one model. This is something like this.
Say an entity is basically a way to group models that have overlapping business logic.
In some way, yes. Yes. So in the simple cases, you don't find such situations, and you will always have a repack you will always have one model by one entity. Yeah, so this probably means you don't need clean architecture there, because you are much simpler, yeah, than this can solve.
And about the repos, their objective is to handle state, or I see you using a get function there, and the state.
So what's the exact question? Okay, so they are only to decouple use case from a concrete storing mechanism. So the most common thing to do is to get something by ID. But if I, for example, has, I don't know, use case that means end all auctions at once. Yes, so there will be another method that tells me get all auctions. So this is an interface between your use cases and the underlying data store. So this example is very, very easy, because the only thing I have to do is I call the Django RM. But in other cases, I might be doing some REST call APIs, maybe use the MongoDB under them, and so on. Yeah. Exactly. Exactly, that's it. Yeah. Only entities. Yeah, so I said that external APIs, let's say that your entity is not stored in your database, your entity is stored in the REST API somewhere. So you want to restore it via, but this is just an example.
In some ways you understand from the framework.
Yeah, exactly. So of course with Django, everywhere you call the Django objects, yeah, because Django gives you everything. But that's just one example. So in different frameworks, like we are using now Pyramid and we have SQL Chemi under, so it looks a bit different. Okay, so thank you all for coming. I'll be there if, yeah?
Yes, one more question. Can you tell us
Yeah, okay. So the first thing to note is that usually IT projects get complicated over time, and what you might think in the first place that it's not suited for clean architecture may end up later. But the good rule of thumb I see here is the Pareto Rule. So it's like, for example, the 20% of my time, I do 80% of work, and so on. So you need to go through the business requirements, the specification, and tell yourself whether the 20% is actually the things that are complicated, or it's the 80%. So it's the 80% that definitely go for it. If it's like 20%, even if you go with classic crude Django application, it will be easier later to just move on. So that's the rule of thumb. Yeah, exactly. This is what I said, that in the beginning you actually know very little, and it will turn out later. Okay, so thank you all for coming. I'll be there if you want.